All right, guys, let's get this last set of free responses going. Here we go. Unit 6. So this is inference with proportions. That's your confidence intervals, your significant tests, the conclusions you draw. And in both of these problems this week, they make the connection between those two. So here we go. All right, so what we've got is this just trying to estimate the proportion of all American or all people in the United States who would indicate that their favorite sport to watch on TV is American football. Now, then it asks you to construct and interpret this 95% confidence interval. That means you need to do a full panic, okay? Now, the solution that they provided did not quite do the full panic and all of our steps per se straight out, but in all of the grading, they did require that you included all of those items. So therefore, in a sense, while they didn't put them all in that order, in particular, they didn't define the parameters straight up front. And that really, I think, needs to be done at top. So anyway, let's take a look at the ideal solution, according to them. They say that you needed to identify the procedure and conditions. There are several parts to this. So they just jumped right here then to the A and the N. That's where they started. So they skipped P, but P should be defined as P equals the proportion of all people in the United States who would indicate, or you could say who indicate or will indicate. Make sure that it's in present tense or future, that their favorite sport to watch on TV is American football. Okay, then the assumptions and conditions. So you had to say that they were random. They actually did not require the independent, but we always include that. N is less than 10%. Okay, and then the large enough. So you had to say that there was at least 10 successes and at least 10 failures. And so it also surprised me that they did not conclude that the approximately normal model applies. Approximately normal model applies. Okay, so those aren't here, but I know based on past free response grading guidelines that that's surprising that they don't require those items. Okay, so there you go. Normal model. Okay, now let's move on. So the scoring for this step was that you did identify, that you would identify, see, we would have named it that we're going to do a 1 proportion Z interval, which we actually do in the next step. Random is checked, sample size, the large enough is checked, and so that's all they did on this part. The next scoring continues and has you construct it. So that's where we would have named the interval 1 proportion Z interval. Okay, it says show work, but I do know that based on past grading guidelines, you could just say the 1 proportion Z interval and then give this right here. You did not have to show that math there. But that's your p hat plus or minus your critical value. And that critical value was based on being 95% confident. Remember that critical value is going to be inverse norm of 1 tail. So if you had your 95% in the middle, then you have your inverse norm of 1 tail, which would be inverse norm of 0.025. All right, so you got this interval here. So essentially correct, you got the correct interval with work. It says with no work, but naming the interval would count as work. Next, interpret. So the third scoring component to this problem was part A, was interpreting it. So we are 95% confident that the true proportion or the true percent of all people in the United States who would indicate that American football is their favorite sport to watch. See, you're defining that parameter right there. Okay, so it is in here. And in fact, that you would have been knocked off if you did not interpret that. See, interpretation is clear that the interval is estimating about the correct population proportion. Okay, so it's all in there, just kind of like in a different format than we do in PANIC. But anyway, it is between 34% and 40%. All right, making sure that you're saying, I am 95% confident that the proportion of all, so you can either say like the true proportion or the proportion of all. Anyway, you're making it clear that you're making an estimate about the population, not about your little sample you got. Okay, so that was part A. Now, part B then says, hey, what happens if, we got another p hat or whatever that was 33%, or somebody thinks it's just a third or whatever. How would that, um, supposing that that's the actual percentage, how would that jive with the interval results you got? And so then in that case, we're asking for that interval and the test connection. And so we would say, hey, you know what? 33% is not in the interval I got. I estimated that true proportion 34 to 40. So therefore, it isn't reasonable to conclude that the true P is 33% because 0.33 is not in that interval that I'm 95% confident contained the true parameter. Okay? And so the scoring was pretty straightforward. You basically say it's not consistent and justify correctly. You have to reference the interval, the 34 to 40 you got. Okay? And so there is that. Next. So this, let's see here. Is this the second? Yeah, this is the second full question. So next question. So this one here, it talks about basically the situation where these people heard they could roll the die and make it an unfair die. So they put it in the oven, 200 degrees, left it in there for 10 minutes, and then when you bring it out to cool, whatever side is up will be the one most likely. We'll make it land on that one more frequently because the cooling melted the inside and made the bottom heavier when you brought it out to firm back up. Okay, so what they did was they then tested it. They rolled the die 600 times, and they had left it so the number 6 was up. So they're supposing number 6 is going to happen more than 1/6 of the time. They got 43. So their p hat was 43 out of the 200. Okay, and so that's what's going to help us draw a conclusion. So they're going to use that to draw a conclusion about the fairness of the die now. So they say, all right, they say, we got a 95% confidence interval, so they didn't even have you do it yourself. They got a 95% confidence interval with 0.215 plus or minus 0.057. So you know this here is your margin of error, okay, which came from many things multiplied together, and then there was your p hat, 43 over 200. So does this provide convincing statistical evidence at the 95% confidence level that the 6 will land up more often than 1/6 of the time? So explain your answer. So what we're going to do is make a conclusion based on the interval. So we've got ourselves the interval, and if we go ahead and calculated that out, the interval is from that 0.158 up to 0.272. So I'm 95% confident that the true proportion of times that particular die will land on 6 facing up is between 15.8 and 0.27. Now, because 1/6 is this and 1/6 is in the interval, that test and interval connection would tell me you don't really have evidence to dispute 0.16666, 0.167, okay? So therefore, we wouldn't have evidence to reject the possibility that the die is still fair. Still could be fair, okay? All right, scoring. You had to calculate the endpoint, so they wanted to see that you understood what this, when they did that, was talking about, so that you basically created your interval. They also wanted you to say that that the interval doesn't, and recognize that 1/6 is in the interval. So therefore, it doesn't support the claim that the die is now unfair. Refers to the proportion of times. Okay, so see, here's the parameter you had to have defined in there. The proportion of times the 6 will land face up, because that's what this problem is about, is the proportion of times the die will land with 6 face up. So it needed all 3 of those items for full credit. Next, now this is an interesting, I really liked this problem. Made the numbers really close together, so I would caution you in rounding 0.1666, 0.1667 to 0.17, because when you move your decimal, that's 16.67%. At the very least, I would do 16.7%. That plays into actually our part C shortly. But let's go ahead and take a look at this. So this one other person says, hey, let's do a significance test. So look at the alternative that she chooses. She just says we want to do it greater than 1/6. So that's a big deal, because that actually changed the problem up a tad from here, when we are just doing 95% confidence in the middle. See, 95% confidence in the middle puts 0.025 up here. So that's different than her putting 0.05 in that upper tail. And we'll get to that in part C. Anyway, she obtained the test statistic 1.83 and a p-value of 0.033. So therefore, do the results of the significance test. So you're going to then start in your phantoms with obtain a p-value, compare it to alpha, make a decision, and state your conclusion. You're going to do the OMS. Okay? So here's the solution. Since the p-value of 0.033 is less than alpha, see, and we would have defined when we were writing ours out, p-value equals this is less than alpha of this, okay? There is convincing statistical evidence. There is evidence that the proportion of times the 6 will land is greater than 1/6. Okay, that's our HA. This does not agree. See, then you had to explain if it agrees. Remember, I've told you, you really got to pay attention to if they ask you to connect to a previous part, you have to. That will definitely be deducted if you don't connect to a specific part they ask you to connect to. So that does not agree with the interval in part A, which suggests that 1/6 is plausible. See, because 1/6 was in our interval in part A, but yet here in part B, we are rejecting 1/6. So they did not go together, those conclusions. All right. Scoring, you had to say the HO will be rejected and have evidence of HA. Okay, of course, in context. Okay, and so then it had to be justified on the comparison of your p-value being less than alpha. You had to reference that specific 6 landing on the face, okay, up, and then stating that it does not agree with the results in part A. Of course, if somehow you didn't get A right and you had the wrong interval for some reason and then it did land in it, anyway, so if you did A wrong, they would carry that wrong answer in part A to your decision here and make sure that those still coincide. All right, next, I love this part. So they're interested in looking at, why is there that disconnect? Why did part A say, yeah, the die's still fair, or it appears, I'm 95% confident that, the true proportions still could be, it could be that. I didn't reject, okay? So here's the deal. We want to look at the difference areas that we investigated with a confidence interval versus hypothesis test. And this is where then on the interval you were asked to show that if we're doing this, okay, then what are we're putting 2.5% in each tail, okay? And so they asked specifically in this to label the critical values. You need to find the critical values. While you may use the confidence level, the confidence level is what's in the middle. You need to do inverse norm of one tail. Inverse norm of 0.025 gives you a z-score of negative 1.96. And then, of course, we know by symmetry, this one up here is going to be your positive 1.96, okay? So we had the positive and the negative 1.96 for those critical values, the z stars, okay? All right, so that was needed for part 1. And then they want to do the same thing for part 2, but remember that in part 2, we had the entire 5% up here. Okay, that's what made the difference. So we have the entire 5% right here. That means I need to do inverse norm of 0.95, and that z-score becomes 1.645. Okay, I actually have noticed that on the AP grading guidelines, they usually carry this one out to 3 decimal places, 1.645, rather than going 1.64 or 1.65, because in actuality it's 1.644, I think it was 9. Okay, so they typically round that one to 3, just FYI. But they accept it either way. 1.64, 1.65, or 1.645. So there's that. So here's the solution. There is the picture basically that I just drew. And so for parts C, you had to label, or the first part of C, you had to label both of those, and you had to do the correct shading and identification of the tails. For the second part C, you had to do this and label that correct tail. Okie dokie. Now, what they're saying on this part D, is, they recognize. He wants to say maybe let's make an interval to see if it's going to land on, just the upper part. So let's put the entire rejection region. Let's make an interval where we put the entire rejection region just right here. So they say, okay, let's do this. 0.05 is here. So then, based on that, we want to create a one-sided 95% confidence interval. So that's interesting. So that means, we have to now kind of think backwards. Well, technically, if I have 5% of this tail, then what confidence, level is this? I guess technically I'm just going to be doing a 90% confidence level, because that's what would be in the middle. But let's go ahead and do this. So let's do our inverse norm of the area below is the z at that spot. So the first part, determine the critical value you would need. So the critical value down there now is that negative 1.645. Okay, so I just need to locate that amount. And so I do that, and that amount is 0.1672. That's where this, if you take 1/6 and you rounded it to 0.17, then you would again say, so if we said this is 0.1672 and 0.17 is inside that, you would then say 0.16 is still plausible, so it still could be a fair die. So that's why I would suggest, and they acknowledged that down here, that if you had rounded to 0.17 and you made the correct conclusion, then they would still give you full credit, okay? But it would be wrong if you used the critical value of negative 1.96. You had to use the correct critical value for that, and then get that correct numerical location right there of 0.1672. So basically, with this, it now will jive with what we did in part B, where she then rejected the null hypothesis, because with if you had the 1/6 of 0.1667, remember, 1/6 equals 0.1667. Well, that would be just right in front of that critical value right there, this lower boundary, and therefore it would not be in the 95% confidence interval, or I guess, well, anyway, they're still calling it 95% with no upper limit. Okay, so the 95% confidence. So therefore, that means that I just am gonna. So in that case, I would reject the fairness. Okay. All right. So I don't like the closeness of all the decimals and stuff, but the conceptual idea of what was going on here is true. So you can see kind of where accuracy, or 4 decimal places when you're doing those percentages, is important in drawing correct conclusions when the numbers are tight. All right, I think that's all of the Part 6 free response question from AP Classroom.